A very good morning, dear students. Welcome to Physics Online class. I would give you a quick recap of what I have done in the last class. We are entered into the chapter Work and Energy. That's supposed to be the last chapter in our physics. And in that, I have done what is work. Okay, what is work done? uh, Work done, we see we are doing so many works, but what is the scientific concept of work done? According to science or according to physics, it involves in two important factors, that is force and displacement. Okay, force is in Newton and displacement is in meter. Okay, Newton meter. That is, when will we say the work is done? The force should be applied on a particular object, and for example, this is an object of A, and this, when a force is applied on this object, it should have moved to some distance. Okay, distance, yes. Okay, then the work is done. Otherwise, the work is not done according to physics. So, what is the work done means when a force of 1 Newton is applied on an object, that force will move the object to 1 meter distance, and that is one unit of work done, that is called joule. 1 joule is equal to the amount of energy or the force that is needed to move an object to 1 meter of distance. That is 1 joule. Okay, this is a work done we have already seen. The important thing that you should remember is it contains only two factors. One is force and another one is distance or displacement. So there is something called positive work done and negative work done. What is positive work done? Positive work done means when the force and the displacement is in the same direction, then that is called positive work done. uh, I am applying the force in this direction, and the displacement is also in this direction. So when both are same, that is positive work done. Now, in case I am applying force on this side, but the displacement is on the other side, we can call it negative work done. That is called negative work done. So positive work done, negative work done. If it is in the same direction of the force, the displacement is of the same direction of the force, that is positive work done, and if it is opposite direction of the force, so it is called negative work done. Now I'm done with the work done. So I have also gave solved a problem. In case now also we can solve one more problem, that is on page 148. On page 148, simple, a force of 7 Newton. Okay, a force of 7 Newton. Okay, force of 7 Newton acts on an object. The displacement is 8 meter. Okay, now the new position is this one. The force of 7 Newton is applied in object and it is displaced to 8 meter. uh, Now the force is in the same direction. Let us take the force is in the same direction. Now what is the work done? Simple, as you already know, the work done W is equal to force into displacement. That means, simple, what is that? 7 into 8. 7 into 8, 56. Okay, 56 Newton meter or joule. Okay, Newton meter or joule. That means the amount of work that is done to move this object. The force 7 Newton is applied to move the object to 8 meters of distance. The work done is 56 Newton meter or 56 joule. Okay, this is one problem, and it's very damn easy problems. But in the later part of this unit, we will go to kinetic energy and potential energy. There we have more number of problems. Now, we are getting into understanding of the second part of this chapter, that is energy. Okay, the second part of this chapter, that is energy. So you know, energy, without energy, nothing can be done. Nothing can be done without energy. Uh, you see, where does this energy comes from? For example, you see the trees are growing. They have a green color thing. You see, the trees are growing in the pot. It gets the energy from the sun. Okay, so sun is one of the greatest source of energy. From sun, it gives energy, light energy, heat energy, so that the plants are growing. This is one form of energy. And there are another forms of energy, like this is a nucleus of an atom. This is an atom. This is a nucleus. You see protons and electrons on the other side of the nucleus. So there are energy that is inside this nucleus. Okay, there is nuclear energy or atomic energy. When we break this nucleus, it can give such a huge amount of energy. That energy is being used to make electricity that we see, um, nuclear power plants are working on this energy. And you see chemical energy, batteries. Okay, you may have batteries at home. Okay, this is a battery. So this gives electrical energy. The chemical inside this gives some energy that can move the electrons, that will create electricity. That is, so without energy, I am speaking. Okay, I am giving some energy, and I speak, and you listen. That also needs some energy. Without energy, you cannot listen. So the whole universe is of energy. Okay, the work is done. We saw what is work. Unless you have energy, the work, there cannot be any work. So we need to do the work. We need energy to do the work. We need energy. Without energy, we cannot do any work. So energy and work are closely connected. We so there are different source of energy, like you have seen the windmills, right? You have seen the windmills. Okay, the windmills are running. The windmills run with the help of light and the wind energy. Okay, the solar power plants are running with light energy. Okay, so the whole world, when you go to ocean, you see the waves coming. Okay, the waves coming in the ocean. That is called tidal energy. So there are different various forms of energy in this world. With this energy we live. Without this energy we can't live. Now there may be another examples, like um, you all are interested in cricket now. You see, there are three stumps. Okay, once a ball is thrown, when it hits the stump, thrown with some energy, it will move the stump and it will make the stump to move in this position. Okay. So what this energy is doing, it is throwing away the stump. Okay, it is doing some work. And what could be the other example, like you see a nail. Okay, you see a nail on the wooden plank. When some energy, when you hit the nail. Okay, when you hit the nail with some energy in the hammer, this nail moves and goes into the wood. Okay, there is some energy. With the energy only we are hitting on the nail with the help of hammer. When we hit the nail on the head, the nail goes down. Best we see in the ordinary examples. So whatever I say, it is not something alien to you. Cricket stumps, when ball hits on the stump will move. The stump will be thrown. When you hit on the nail will go inside the wooden plank. Okay, it's a very ordinary example. Or else, so when you there is a toy car. Okay, so these are examples that are in the book. So I'm doing a toy car. Okay, when you pull the toy car, early days there will be a key. When you rotate the key and you keep the toy car, it will run. So there is some energy stored inside. Or nowadays you are playing with a remote control car or a battery car. There is some energy inside to move the car. So energy we see age in every place. So what can we say? An object which has the capability to do work, it possesses energy. Okay. On the other side, how can we say? If an object has energy, it has the capacity to do work. Okay, this is a hammer and a nail. So, when this hammer contains an energy, it can do the work of hitting the nail. Okay, if the particular object does not have the energy, it cannot do any work. So, work and energy are closely connected with each other. If you have energy only, you can do the work. Or else, if you have, if some work is done, then you can say it possesses energy. So both are interconnected things. Now, when an object gives the energy, when something is done on the object, this object will lose energy. Okay, but on which the work is done. So the object which is doing work will lose the energy. For example, I am doing work, not this work and scientific work is different. For example, I am saying when I speak, I have an energy. I speak, the energy is released as a form of sound energy. Right? So I lose energy. So when the work is done, that object loses energy. So the other object on which the work is done. So there is a nail on the other side. The work is done on the nail. So it gains energy. Okay. So one who does work loses energy. One who gains the work done on which the work is done, it gains energy. So, what is energy? Energy is the capacity of doing work. If there are more amount of energy, more work is done. If there is less energy, less work is done. If there is no energy, work is not at all done. So, what can be the unit of energy? Of course, the unit of work is the unit of energy because work is determined by the energy. So, what is a unit of work? Unit of work is joule. So, the unit of energy is also joule. So, during this time, what happens? Particularly, you can see this energy is transferred from one form to another form. Okay, when some work is done on the object, the energy is transferred from the particular object to another object. You can see there are very good examples like you are turning on a fan. The fan is rotating. Okay, how it is rotating? It is from the electrical energy you are doing, but it is rotating. Rotating is a mechanical energy. So electrical energy is converted into mechanical energy in the ceiling fan. Okay, you are using a heater or you are using an iron box. What happens? You are switching on the iron box or you switch on the heater, the object gets heated. The iron box gets heated. How the electrical energy is converted into heat energy or electrical bulb. What happens? Electrical energy is converted into energy. In windmills or wind turbines, no? Windmills, what happens? Wind energy is converted into electrical energy. So this is called a universal law of conservation of energy. It says energy can never be created nor be destroyed, but it can be transferred from one form to another form. Okay, one form to another form. Uh, Wind energy can be converted into electrical energy. Electrical energy is then again can be converted into mechanical energy. Mechanical energy can again convert into chemical energy. Chemical energy to electrical energy. So energy can always be converted from one form to another form, but it can never be created nor be destroyed. This is law of conservation of energy. Maybe this law may come in the last part of this unit that I will teach. So, different forms of energy I said, and different types of energy. I will get into the next class. That is very important topic. That is potential energy, kinetic energy. So you have some problems and the theory on this topic. Okay, what I have given is an introduction to energy. The last class I have given an introduction to work. This is also an introduction. There is nothing we have done seriously. It's an introduction to know what is energy. Energy you have, and with the help of energy, you do some work. What, according to the science and according to physics, what is work? The force should be applied and object should be displaced. So energy, work, force, displacement. Now you understand the logic? Okay. Now you understand. Now, what is this energy? How the body possesses an energy? That is two types of energy, potential energy and kinetic energy. That we will deal with the next class and the problems related to that. I hope you have understood what is energy now, the capacity to do work. And I said the unit of energy is 1 joule. And how can we define this 1 joule? Is an energy, joule is energy required to do work. An energy of 1 joule is the amount of work done on the object to make 1 Newton of force to move an object to a distance of 1 meter. Okay, same. 1 joule is equal to 1 Newton meter. So energy and work are closely related, interconnected. One cannot be without the other. Okay, I hope you have understood the things. Slowly